land degradation is affecting currently 3.2 billion people worldwide, and this land degradation has reached high level in many parts of the world. By 2030, most vulnerable people will suffer from a global decrease in food production due to more frequent crop failures and an increase by nearly 1 billion hectares of degraded land, provided a similar land degradation. Therefore, then, business as usual strategy for agriculture, land use and land use changes will impede the contribution of food systems to the net zero CO2 emission ambitions. To address this issue, we are very pleased in this side event co-organized by the National Council for Climate Change, Sustainable Development and Public Leadership from India, the International 4 per Meal Initiative, Soil for Food Security and Climate, CIRA, the French Agricultural Research and International Cooperation, and IRD, the French National Research Institute for Sustainable Development. So again, we are very pleased to have you on here. So soils provide multiple ecosystem services. As such, soil health management should consider at least 3 points. Enhancing many ecosystem services requires multifunctional management. Managing soil to improve one service can have positive, synergetic, or negative effect trade-offs on other services. Soil health management should sustain soil services over a long term. The soil health concept emerged from soil quality in the 90s. Since then, it has gained in importance. In the scientific arena, you can see on the slide some example. And if we look at the web of science from 2000 to 2023, almost 6,000 of scientific papers have been published in peer-reviewed journals addressing soil health in a large diversity of domains such as environmental sciences, ecology, agronomy, forestry, and many others. Soil health has also gained momentum in the political agenda at the UN level within land degradation, with the land degradation neutrality target, which is one of the targets of SDG, target 15.3, with several special issues published by IPCC, IPBES, at the EU level with the Green Deal, at the African level with the Union African Initiative on Soils, at the international level, as I said, with the 4 per 1,000 initiatives. For this event, we managed to gather an amazing panel. So each panelist are going to introduce her or himself. And the panelists will share their vision on pathways for healthier soil to meet food and climate goals in diverse socio-economic contexts. That is our ambition. And our other ambition is to have you on board, to give you the floor. So do not hesitate to take the floor. We need to have your input to enrich the debate. So, without further ado, I will give the floor to Dr. Dey Hélène Diallo-Diagne, and she will introduce. Over to you, Hélène.
Thank you. My name is Dey Hélène Diallo-Diagne. I am a soil scientist at the Senegalese Agricultural Research Institute. And please me to share with you. Please allow me to share with you my presentation with that entitled Mais ce n'est pas ça le titre. Okay, it's okay. The title is Agroecology and yeah, and soil health, myth or reality. And in the particular case of Senegal, what is our context? Okay, there's some problem with the presentation, but our context is we are in a country we face with low soil organic matter, low fertility, soil fertility, and low yield. It means agroecology should be a response for a problem to solve the yield decreasing and also the problem of the agriculture, whether in terms of water management, protection against erosion, and or soil fertility management. Why? We get some results from previous studies that show us that we have, and this one is from 2021, and show us we have low soil organic matter below, the content below 1.35, and also low level of nitrogen. It's the same with phosphorus and potassium. Means we have to bring solution with our low level of low nutrient level, and this case shows us we have a reference point, and it is important to have data to develop strategy for reclamation. And for that, we have a political engagement, commitment in Senegal, and the government since 2014 developed some strategies and programs from biological platform to program on organic fertilizer. And the main point are agroecology is taken account in the group of the ministry, and the Senegalese government is subsidizing the organic fertilizer. Also, we have a coordinator of agroecology, and we have to reinforce the water forestry system against deforestation. And also, we have an establishment of younger support, to develop the agroecology in around the country. But we have also a community support and networking program, starting with co-designing system and tools with farmers, because it is important that the best available science results reach to the farmers, and they can bring it to the local knowledge. And so we can ensure that we will have adapted strategy, adapted method to face our challenges. And we promote also the product of agroecology or biological product on the trade fair. But something important also is to make all people together, to bring them together in some organization. And in Senegal, we have the DTIS. It means it is a group that is that work with agroecology, and they are making policy brief and try to sensibilize and bring new technology or agroecological practice to the community. Also, another level it's important in Senegal is that education, and we have diploma and degree at the university. It means we have younger people who can get training on agroecological courses. University graded and training center are developing those courses. And our next step, or some point we would like to share and develop in the future, are to put farmers at key agent of the shift, to reverse degradation or to improve soil health, because they are the key agents. Also to build the capacity of all the actors and develop a policy who can encourage and facilitate the implementation and adoption of agroecological alternative, because we have problem of low adoption of results between farmers. And we need to success our scaling up. We have low adoption, we need to success that. And also, we need to have a structured and remunerative market for that product, because there is no difference between those who are selling product from agroecology and those from conventional agriculture. And agroecology strategy need more finance, more funding, and for us, it has to be a shared and a collective commitment of all stakeholders to be success. Thank you so much.
Thank you so much, Hélène. So we have learned that agroecology in Senegal is not a myth, it's really in motion. Training, capacity building, already action on the ground. Thank you so much. So the next speaker. Yes, please.
Good afternoon, respected all COP members. A big hello and namaste. My name is Sushil. I'm from India. The National Council Climate Change Sustainable Developments is working with various NGOs. One of the NGOs, VRTA, Vivekananda Research and Training Institute, are working with the mass level of farmers in Gujarat and Maharashtra. So my topic is natural farming for combating climate change. On behalf of Dr. Kirish Shilat, is the Executive Chairman of NCCSD, so I will present my presentations. The natural farming means sustainable agriculture. The sustainable agriculture is a farming and food production approach that aims to provide a long-term environmental, social, and economic benefits. There's various key principles of sustainable agriculture, include like soil health is very important, because vermicomposting, green manure helps to improving soil fertility and structures. Second is water conservation. So farming should adopt a strategy including micro irrigations, rainwater collections, and other use of water for the efficient crops. The crop rotations and diversification is very important, because planting a range of crops in a particular order to improve our soil structures, break up pest and disease cycles, and minimum use of the chemical inputs. The organic farming avoid the use of synthetic fertilizer, pesticide, and genetically modified organisms. The promotion of indigenous crop means local crops. The indigenous and traditional crops that are better adapted for the local conditions require less inputs, promotion biodiversity in agriculture. So climate smart agriculture is another important point, because this involves the conservation of agriculture, the use of crop resistance to drought and other methods of adjusting the changing the climate circumstance. Capacity building, the various NGOs, non-government organizations offering education and training, it helps to spreading the information and helps to sustainable farming. Social responsibility, fair labor practice, community engagement, people participation is very must. So economic viability, fair trade method, it encourages the developments of local markets and short supply chain. Government initiatives, the Government of India has implemented various schemes like NMSA, the National Missions for Sustainable Agriculture, and the PKVY means Paramparagat Krishi Vikas Yojana. They're all supporting the organic farming, soil health management and water use efficient. Energy efficiency, the solar panels, wind turbines, biogas systems generate the clean energy and lowering the carbon footprints of agriculture operations. Here the natural farming based on the 4 pillars. Seed nectars. Seed nectar means it's a mixture of water, cow dung, cow urine, lime and forest soil, which is used to treat the seeds for protect from the soil and seed-borne pathogens. Another pillar is life nectar. It is a mixture of water, cow dung, cow urine, jaggery means unrefined brown sugar, flour of any pulses. When applied over soil, that promotes the biological activities and adds the soil microbes. Another pillar is atmosphere. Atmosphere means the mixture of the 50% air and 50% water vapors in the cavities between the 2 soil particles and is the building up soil's humus to increase the soil erections. And the last one is mulching. Mulching is a very important component of natural farming. Organic materials are used to cover the soil, conserving the moisture and controlling weed growth and promotion of soil health. So these are the very useful for the natural farming. Thank you very much.
We have heard from your expertise and your experience on that again, you know, training, capacity building,
yes.
Political will and strategy, but also co-construction if we want to make healthy soil be part of the solution. Thank you so much for giving us this flavor from India.
Thank
you. So, Jérôme?
Okay, thank you very much. Good afternoon, everyone. My name is Jérôme Tondoh. I'm from Côte d'Ivoire. My background is ecology and sustainable management of soils. So I'm going to share a couple of slides with you on what is going on in Côte d'Ivoire in terms of land degradation. As you know, Côte d'Ivoire is a top country producing cocoa and other tree-based commodity, and that goes with a lot of issues in terms of land degradation. So, first of all, up to 80% of forest cover has disappeared over the past 60 years due to agricultural, activities. And we suspect strongly cocoa to be responsible for that, one of the major drivers of this disappearance. To give you an idea of the pace at which the degradation is taking place, from 2000 to 2009, up to 3 million, cocoa led deforestation took place in Côte d'Ivoire at a rate of 120,000 hectares per year. So this gives you the idea of what is going on there on the ground. So of course, we know about what's going on in the above ground community, but what is going on in the soil? That is a big issue, and because we don't have so much figures in terms of degradation, but we do estimate that up to 70% of the soils are degraded. So a lot of consequences may derive. For instance, the issue of yield gaps is crucial for, attaining food security. This is one of the first issues we are facing. This slide gives you a kind of overview of what's going on globally. We can see that Western countries are doing well in terms of, agricultural production when you take into account maize and rice. But the BRICS also, they are doing well. Brazil, China, and so on. But when it comes to Africa, we are lagging behind. It means you have some issue with soils that we need to fix. When we take into account the rice, we know that most of African countries, they do, I think, export rice from Asia countries because, of course, the production is still low. Even there, there is no clear, I think, a trend in terms of who is taking the lead, but we can see here that USA is taking the lead, although I'm not sure they are eating rice so much there. So this is to give you an idea of what's going on. In Côte d'Ivoire, for instance, cocoa, although you are the top country producing cocoa, but the yields are so low. Even cashew, you are the top producer in cashew beans, but the yields are so low. The same stands for maize and rice. And we do think that the issue of land health has to do with that. So if you want to fix that, if you want to bridge that gap, we need to, bring in some cropping approaches that rely on innovative, technologies. The second consequences due to land degradation is the recurrent soil, organic matter, and nutrient mining. For instance, we did a survey, a baseline survey in cashew landscape, and we realized that if we consider site level, even regardless of the type of land uses, the soils are degraded because if you take into account the threshold of soil organic carbon, most of sampling point, where we collected soil samples, the concentration of soil organic carbon is very low, below the threshold level that can support cashew production. So that brings us to the solution, how to deal with that degraded landscape. We think soil health has a role to play. It is a key concept that can be used to restore degraded landscape, talking about soils and also bridge those gaps. So right now what we are promoting a couple of, innovation in the country. First, as far as cocoa is concerned, we are promoting deforestation-free cocoa, cropping. And it has to do with cocoa-based agroforestry, the promotion of cocoa-based agroforestry, also the use of organic amendment, poultry manure, biochar derived from, crop residues, and green manure, and integrated soil fertility management as well. Secondly, the agroecological transition to intensify, the production, not as we know, but we want to rely on the deliverance of ecosystem services to support sustainability in a sustainable way, agricultural production. Also, the diversification of crops. Most of the tree-based commodities are used as, monocropping systems. We want to get rid of that approach and promote diversification in agroecological systems. For instance, the cashew sector, needs those kind of innovations. Agroforestry, intercropping, and crop rotations. So why are we promoting those technologies? Because they have beneficial impact on soil erosion reduction, improved carbon storage and sequestration, enhanced, nutrient cycling, conservation of soil organisms. This is very important because most of the time when we talk about soil health, we neglect, these key components. So we want to put an emphasis on that, and also by putting all these conditions together, we want to, go for sustainable agricultural production. So right now the government has set into place a major initiative to tackle the issue of land degradation and ultimately soils. So we call it Abidjan Legacy Program that relies on four pillars, and of which one is exclusively tackling the issue of soil and land degradation. So I mentioned in my previous slides that the first one, that the issue we are having is the data issue. We have no knowledge about the trend of soil degradation. So I think we are lucky because we will be running a program, one of the components of an AU program on soils in Africa will be, I think, taking place in my country. And you can see at the left side the way the sampling, I think, a point are scattered all over the country. So we'll be going at each of the points to collect soil samples and characterize them by measuring, I think, the different soil properties. And that will help us, I think, bridge the gap of soil, I think, soil information, and come up with recommendations as to how to manage efficiently those soils. What is very interesting here is that the country is, I think, allocated in various, I think, agroecological, ecological zones. So we are going to use those mapping to make sure that we can come up with, for each specific area, recommendation as to the proper way to manage those soils. So what is the take-home message? First, soil health can be used as an antidote to soil degradation and agroecological vulnerability, ecosystem vulnerability, sorry. The ongoing climate change should be seen as an opportunity to come up with, I think, technologies based on, I think, the promotion of soil health to, I think, go forward in terms of sustainable agricultural production, productivity. So the issue of soil health should be, I think, considered holistically, not only by relying only on physical or chemical properties. We do think that the biological component is key to this concept. So we need to put a kind of specific emphasis on that as well. So we also need to see how we can use the concept of soil health to address, I think, what we call disaster risk, I think, that unfortunately so frequently happen in African countries. So we also think that the emphasis will be put on the role of agroecology as a nature-based solution. After all, we are not going to duplicate, I think, the mistake, I think, that was, I think, linked to the, I think, the Green Revolution. We need to think out of the box so that we come up with a very strong but sustainable way of boosting agricultural productivity in Africa and Côte d'Ivoire specifically. Thank you for your attention.
Kapil from India, and Jerome told us that we need to prevent, that preventing is better than cure, and we need to be able to look at early warning system when soil health is starting decreasing. So you have the floor. Thank you, Dr. Kapil.
Good afternoon, sir, and thank you so much for giving me this platform to share my experiences with all of you, and to indeed learn from the experiences of my colleagues here. The last week has been a very intellectually stimulating week for me. But unfortunately, I haven't met anybody who's in my line of work, so perhaps you'll find this unique. Let me introduce my company first. So I work for...
Maybe you can put your slide on.
Yep.
Yeah, thank you.
I work for ICSER, and this is the CSR initiative of 3 public limited companies, Excel Industries, Pidilite, and Mamta Group. And we are committed to the study and research of marine macroalgae, in fact, the entire ecosystem of the seaweed. So I would like to briefly go through the journey of our work and share with you our experiences. It's been unique in many ways. We began by setting up a tissue culture laboratory to micropropagate the 2 species of seaweed among the thousands that are prevalent. We selected Capaficus alvarezi and ulva, and I'll explain to you why we selected these 2. So essentially, what we did was when we were satisfied that the seeds were sufficiently hardened, we transferred them to pilot tanks, something like these. We had 2 sets of pilot tanks, and we then learned the actual growth cycle of the seaweed. And when we were satisfied that we had a robust model, we validated our research work by transferring the propagule into offshore farms at sea. These farms were located some distance from the shore. So it varies from 4 to 5 miles away in depths of water of 10 to 15 meters. And then we validated our system by checking out the growth of these 2 seaweed that we had selected. And we found that we were satisfied with the DGR, that is the daily growth rate. And then we eventually were ready to transfer this technology to the coastal communities living along the coast of India. So these are typically farming families or fishing communities. They depend on their livelihood on fishing and coastal farming. But fish catch is dwindling all over. And we thought that this would be a very good means to encourage livelihood, not as an alternative, but as an additional. So from there, we then decided to move on to another research work, which is we took 2 other species, Monostroma and Glaciolaria dura. And I'll explain to you why we selected these 2. We did research work on these 2 species with CSM, one of the leading research organizations in India, and TIFAC, the Technology, Information and Broadcasting. So we, in fact, then took up this work in a systematic manner, but this is still work in progress as much as ulva is. Now, we know that there is a dilemma here. Why are we excited about seaweed in particular? Yeah. Why are we excited about seaweed in particular? And the reason is that, and I'll share with you, there are 6 very good reasons. I'll share each of these with you. And we found that this is possibly a solution. So what's the dilemma? We know that, for example, economic growth definitely requires increased consumption of energy. On the one hand. On the other, we have a cap placed on, carbon emissions. So this dual challenge needs to be, addressed in a systematic manner. And I recall the Paris Planet and People Declaration, which said that no country should have to choose between fighting for poverty or fighting for the environment or the planet. So that's the reason we have selected this macroalgae as one of the solutions, and I'll share with you 6 good reasons why we feel that this is something that can be developed. We all know that growing plants and trees is good for the environment, but plants require land, they require fresh water, and they require fertilizers. The first two are stressed, right? So here is one of the plants, very few in fact, which neither requires any soil, nor requires fresh water, nor requires any fertilizer. It gets all this nutrition from the sea. It not only gets its nutrition from the sea, but also absorbs excess nutrition runoff from the waters. So it helps to balance the oceans. We know that the excess fertilizer runoff has caused havoc in some of the oceans, and this has been shown to, growing macroalgae has been shown to address that matter. I'll also explain to you why I feel that this particular cultivation methodology addresses the Sustainable Development Goals of the UN 1, 8, 13 and 14, and it will be apparent to you as we go along. And the fourth, something which is very exciting to us, is that although we have a good value-add product, we capture carbon while it's growing. So like other plants, this plant captures carbon to synthesize in the presence of sunlight. And the exciting part is that whereas all other plants, terrestrial plants, we can quantify the carbon that is captured by sending a sample to the laboratory and quantifying the carbon. So for example, when we harvest seaweed, it is typically in 95% moisture range. We can solar dry it to down to a few percentage points, send it to our laboratory, measure and quantify the carbon, and we know what it is captured. But the exciting thing is that there is another element, because the baseline of this life cycle assessment is in fact lower. And the reason is that whereas we not only are absorbing and capturing carbon, but there is also an element of reducing carbon which otherwise would have been emitted into the atmosphere. So for example, I use my seaweed to process and make biofertilizers, biostimulants. So what I can do is I can compare what carbon emission would have taken place had biostimulants not been used, and by the use of, let's say, chemical fertilizers, whether we're talking of nitrogen, phosphate or potash, or a combination of DAP, supersulfate, whatever. They are all chemical processes which emit carbon. So we are in a position to then compare what we have saved by not using a chemical fertilizer and using biostimulants. Biostimulants are different, as you're aware. Now, that brings me to the fifth point of the socio-economic impact. That's a huge impact for a country like India. As I said, one of the huge advantages that we offer this not as an alternative employment, but as an additional means of employment. So the people continue their fishing activities, continue their coastal agriculture, but they can also employ the excess people in the family to do this work. And the best part is that this is a sustainable livelihood right in the village itself. There is no migration of rural people away from the village. One of the things that we noticed is that whereas we all want to encourage the most vulnerable sections of society, the women, we found that this particular cultivation method gives us employment for both. So we can use the seeding and harvesting methods and work by women on land, on coast, and do the harvesting and the actual farming by men at sea. So we don't destabilize the social fabric by giving employment only to one set of people. We can have a mix of the entire family working, and we have set up now guidelines as to how much a typical family can cultivate in square meters, which is viable for that family. And this, like I said, is truly a grassroots initiative which is owned by the people. Now, I during the work, we also realized that we need to create a model to benefit the coastal communities. So we have had success with two models, and I'll share these with you. The first is, initially the fishing community is not confident of seaweed as a sustainable means of livelihood. They're not confident. They know that if they spend 10 days at sea, they'll get so many kilograms of fish, but they're not sure about this. So we said, all right, we will pay a daily wage to the family, and you have an assured income. We will we will take the seaweed as it is harvested from you, and you are then assured of a daily income regardless of the produce and the yield. And then, of course, like I will explain later, we have a process for value adds on this. But once the capacity has been built in the community, I think I'm running short of time, we find that it is better to allow the community itself to become an entrepreneur. And we have found that one of the best ways to do this is to create a self-help group, a community within the village people, say 30, 40 people all together, families getting together, and they say, right, we will buy our own seaweed, we will buy our own cultivation method equipment, we will cultivate ourselves, and we will then sell it at the market price. So then they are able to get a better rate and a assured income, and then, of course, as they work harder, they get better yields, and they're able to cultivate more. I want to share more, but if I'm falling short of time, I can stop here.
No, 1 minute.
1 minute, thank you. So this is typically how a training program looks like. We gather, we have ladies who go around explaining how to seed. This is an artificial substrate that we have to create to put the propagule in, and we go around training the women, and when they're satisfied, they start the work. I've explained some of the types of seaweed here, like I mentioned to you. These are some of the varieties. There are thousands, but these are the ones that we have selected for our work. The sixth, let me go to the next one. The sixth source is the actual value add that we get from the raw material. Now here I've explained some of the species that we've been working on, but I'll briefly go through some of them, the important ones. Capophycus alvarezi, we are able to extract K-sap from this, and from K-sap is based as we get a formulation for biostimulants. We also get K-carrageenan, and which is used in the pharmaceutical and the nutraceutical industry. We are able to grow euchemia, and then we are getting iota-carrageenan from this, which is the raw material for the bioplastic industry. Bioplastic, incidentally, is truly environment friendly in the sense it is not only bio-derived, but it's also biodegradable. So it's truly an environment friendly alternative to the chemical plastics. Glaciolaria species is used to get agar polysaccharide, and which are then used in the food industry. And then we have Aspergopsis, which is very interesting seaweed. There is a lot of research work out there in the open which goes to show that a mixture of a percentage of this seaweed into animal feed reduces the methane generation formation in ruminant livestock. So I think I'm run short of time, and thank you so much. I'll be happy to take questions later on.
Thank you so much. I like very much, all the process and the way that you have addressed the way to increase soil health and to avoid, land degradation, making, people aware of that, helping them to explore another way to do that. Thank you so much for that. So now we will have Marie Rabonsky from CIRAD. Marie, are you there? Marie is connected through Zoom. Marie? Yes?
Yes. Do you hear me?
Yes, it's over to you, Marie.
Okay, thank you very much. I am Marie Rabonsky. I'm a senior researcher in political science from CIRAD. I had to be in Dubai, but I have the COVID, so I have to be behind my computer, so sorry for that. But my presentation deals with public policies for soil health, some policy instruments, recommendation. So first slide. I know that you are very short, you have only 8 minutes, but to begin, I would like to remember that soil organic carbon stock is twice the amount of carbon in the atmosphere and 3 times that in the vegetation. Sorry, I have a problem of sound. So increasing soil carbon builds a precious reservoir and helps to offset greenhouse gas emissions. And moreover, soil organic carbon stocks have many potential co-benefits for adaptation, for food security, biodiversity, groundwater stress, and water quality, soil health. So the healthy soil approach allows to combine adaptation and mitigation objectives, and consequently policies for healthy soils should be reinforced. So globally, national level and subnational climate policies have increasingly included a variety of incentive programs to encourage farmers to undertake on-farm activities that sequester soil carbon. But based on our studies in global north and south, we can observe that in fact, there is very few public policies which are focused on healthy soils. So based on these studies in global north and south, public policies for healthy soils, I will propose you 4 recommendations. Next slide, please. Recommendation 1, developing and recycling incentive policy instruments for healthy soil. Classically, in political science, we identify 3 types of policy instruments. First, we have STIC, which are some command and control measures. Second, we have carrots, which are some incentive measures to modify a practice. And third, some communicative policy instruments, which are based on communication. Based on our studies, we can say that soil health is a public good, which is provided by farmers. Consequently, incentives should be given priority. Public intervention should be reoriented and reinforced to promote incentive healthy soil policy instruments. But how? First, in recycling existing instruments. For example, in the CAP in Europe, some measures were reoriented in favor of healthy soil. In US, lots of programs were reoriented in favor of healthy soil. So in southern countries, states, World Bank, and international heads could integrate more objectives in favor of healthy soils in their project. Second, we could also create new incentives instruments for healthy soils, such as well-designed payment for environmental and climate services, land retirement policies, afforestation and research and development incentives, and voluntary carbon offset market. I think about the Article 6 of the Climate Convention, which is negotiated in this moment at the COP. Next slide, recommendation 2. Improve the targeting of farmers, especially family farmers. In fact, we have, to integrate healthy soils in the public policy, we have a big challenge, which is the challenge of the target. Family farmers are some key players for healthy soils and mitigation, and should be more targeted by healthy soil policies and instruments. To remember, a recent report showed that 0.3% of climate change funding reaches a family farmer. So you have to increase it, and improve targeting of family farmers is a major is a key player. It's a major challenge. We have also to improve targeting towards land owners and align incentives with land renter. So our recommendation is to shift marketing to target all private landowners and farmers, especially family farmers in the north and especially in the south, of course, which are some key players for mitigation actions in agriculture. Next slide. Recommendation 3, increasing funding for technical and communicative assistance. Our studies in the global north and south showed that many barriers are very high, and it's a problem for adopting some soil health practices and carbon sequestration practices, because there's lots of administrative and operational challenges. In fact, based on our studies, we discovered that according to farmers, there is lots of transaction cost to develop practices in favor of carbon farming. So it is important to assess the cost to farmer of implementing new activities, and also reduce red tape due to stacked incentives. It is also important to reinforce the capacity of local governments. Indeed, our studies showed that effective implementation of local plans for healthy soils can go beyond the capacity of many local governments. So it's important to reinforce their capacity. It's also important to reinforce the capacity of agricultural organizations, technical organizations. Studies indeed have shown that technical assistance is insufficient for farmers due to lack of capacity of local staff and underutilization of partnership, lack of knowledge of practice, and lack of information on soil health. So it is very important to reinforce this. So our recommendation is to increase funding, of course, for technical assistance, focus on communicating the many agronomic and ecological benefits of healthy soils, rather than only promoting carbon pricing as the main motivator. Next slide. Recommendation 4, develop public-private instruments for healthy soil. A policymaker could indeed increase public-private partnerships. Family farmers in the south and in the north could integrate some national, bilateral, or international voluntary carbon offsets. I told you about the Article 6 of the UNFCCC, based on a public-private partnership. And over a longer time horizon, policymakers may also promote market demand for crops grown through sustainable practices and agriculture more globally, such as a low carbon label in France. So both of these represent cost-efficient and scalable alternatives for developed and developing countries, as they leverage participation by the private sector and create long-term incentives for farmers to adopt soil health practices. Thank you for your attention.
Thank you so much, Marie. And it was very on time, to have you on board because of your 4 recommendations after our previous speaker. We wish you all the best, Marie. And so now, Dr. Patak, over to you. And keep your question. After this presentation, we will have a Q and answer session. I hope that you will jump to take the floor. You are most welcome. The floor is yours.
Okay, thank you. Good afternoon to everybody, Honorable Chair, my colleague, and I am going to speak on the soil health management. Now, one of the World Soil Scientist and the World Food Prize winner recipient, Dr. Ratanlal, suggested that all life depends on the soil, and there cannot be no life without the soil, and there cannot be no soil without the life. So both they have evolved together, and therefore the importance of the soil is more. We know that the soil can nourish the plants. It maximizes the carbon fixation, and while minimizing the release of the carbon dioxide, means it is helping to or reversing to the effect of the climate change. And we also know that the soil is the second most carbon sequestration entity in the world after the ocean. And then, but in spite of that, the agriculture soil also can contribute to about 19% emission. We also know that the soil health has different principles. Something, if we have to maintain the soil, then something we have to maximize. As for example, vegetation, crop diversification, some of my other colleagues have already told it. And then something we have to minimize also. What to minimize? Minimize means the degradation can be conserved. Then even the utilization of the less utilization of the chemical fertilizer, and also the minimum disturbance. There are many things which I have already listed in my earlier part, but due to paucity of the time, something we have to delete also. But the soil health has the direct relation with the productivity of the crops. If soil health is good, then we can get the better production of any crops. And we know that my earlier speaker also mentioned that the soil health depends upon the physical, chemical, and the biological properties of the soil. And therefore, what is soil health if we say? Then better soil health is such a soil which has a better capacity to provide the nutrient and water to the plant as per the need of the plant. And therefore, the many things, even one of the saint, Vasudev Jaggi, also mentioned that the soil health management helps in mitigating the climate change. There are many ways, things. Now, in order to know the soil nutrient status of the soil, what has been done in the Gujarat and in India, that I will have a case study and that I am going to present. That our Honorable then Chief Minister and now presently the Prime Minister Narendra Modi suggested that each farmer must know the fertility status of the soil. As for example, we also have our own report of our own body, like even blood, then other things. So such a things that the farmer should also know the fertility status of the soil and soil health. And therefore, the soil health card system was developed in 2004-05 in Gujarat, and which covered about the 40 lakhs farmer. Now, what is this in this soil health card? Now, from each farmer field the collection of these soil samples, then chemical analysis in the soil testing laboratory, then distributing the soil health card, and then whatever the chemical analysis has come, it has gone to the server where the validation data of this is being done, and it is a IT-based system, not from soil testing lab to Anand Agriculture University in server, and that server is, we know that whole program, it is a Krishi Kiran program. And there the card is being prepared based on the soil data, and recommendation for the fertilizer is given on that card based on the soil fertility status, means what is the organic carbon content of the soil, what is the phosphorus content of the soil, what is the soil pH, what is soil potash content, what is the soil EC. Based on that, the farmer gets the written suggestion for his crop. That is the beauty of this soil health card. And for each field of the farmer, that this soil health card is being prepared, and it is being distributed through the government Department of Agriculture. And then the same thing, as even I suggested that there are 12 parameters which is being included. And now even someone say that if you have taken only the organic carbon, pH and NPK, then what about the other parameters? Other parameters are also being taken up, and for that it is a village base has been taken, and more than 6,000 village map for micronutrient content has been prepared in the Gujarat, and the same is being utilized for the guiding the farmer. Now this is a success story that based on that farmer will suggest, will know that how much he has to apply chemical fertilizer, how much he has to give the organic fertilizer to the soil. And so moreover, again one of the important thing that we in this soil health card are also recommending for the alternative crops to be grown, which is based on the available water content, moisture availability index, and then length growing period. That is based on that the farmer will also get, if I am growing the paddy or the rice every time, then what should be the another alternative crop for me which can give the better profit than the rice. That is also being suggested in this soil health card. So this is nothing but what I have spoken that has been given. So alternative crops and generation of the model action plan is also being given. Such a now 42 lakhs means 4 million soil health card has been distributed to in Gujarat. And the same I told about the macronutrient also. Then the same thing has been now repeated in 2015 in the country level. And based on that, the more soil health card, what is the outcome of this now? Outcome is that the 5 to 6% yield is increased, chemical fertilizer is also reduced to the 8 to 10%, means the farmer cost has been reduced to, and the another governmental program is the Paramparagat Krishi Vikas Yojana, which is based on the organic farming, so that soil health can be improved. Neem coated urea, which is means the nitrogen use efficiency. If neem coated urea is there, then it will in atmosphere the less nitrous oxide is being then, and for even less quantity of the urea, the farmer get the better benefit. So cost reduction, and then it is also environmental benefit. Then National Biogas Manure Management Program, the farmer also this biogas plant has been installed at the farmer's level. They can get for their animals dung, and then biogas is being also there, and there will be also the slurry for the soil nutrition part. Mission on agroforestry is there, then Green India Mission. And the last one is the National Mission on Sustainable Agriculture, what my friend has also told. It is nothing but it is a organic and natural farming. Now there is a difference between organic and natural farming. In natural farming, farmer has its own resources, so he has not to buy anything from the outside. This is what the soil health management in the India has been taken up, and there are many studies, but due to paucity of the time, I could not give in detail. Thank you very much.
So thank you so much for the panelists. So, and we have seen that, based on, the description of the parameter of soil quality, we can move at the larger scale to look at what is soil health about in order to connect, this parameter with productivity and other soil function. So we will spend some time and we will give you the flow to address any question, to jump into the discussion, to have controversial input. We need that for us to move on. And after that, Paulus, the Secretary Executive of the 4 per 1,000 initiative, will wrap up and will share with us and you his key message. So please introduce yourself. If I may, could you be sharp, straight? More question, better would be the discussion. Thank you so much.
Thank you. My name is Dosai-Kwe. I'm from Togo. I work with IFDC, International Fertilizer Development Center. I'm the director of Soil Health. And that's why I came to this session. And I want to thank all the presenters for the presentation. It's a learning process, and we all get something from any presentation we have. I'm not bringing questions. I'm making a few comments for the audience. There is a difference between soil health and soil fertility. Soil health, a healthy soil, of course, has a very good fertility. So that's the first thing I want to say. The other thing, I noticed that there was some interest in soil fertility mapping, because it's very important to know the soil onto which we are growing crops in order to tailor the recommendations. That's very important. But I want to bring a point of attention here. It's not only knowing the fertility of the soil that will solve all the issues. Now, it's how we use that information, because if you base your recommendation on soil fertility mapping alone, then you may end up having 100 of recommendations for smallholder farmers, which is not scalable. And most of the time what we want to have is a best bet, not the best fit, at least for smallholder farmers. So it is in that vein that I wanted to share with you what we do at IFDC. We have one way of doing that thing, the space to place approach of fertilizer recommendation for smallholder farmers. We combine digital soil mapping information with local information, plot scale information, taking into consideration the farmer's capacity, his inclination for some specific practices, and also his ambition in terms of yield to make recommendation for that farmer, what he can afford. At the end of the day, any recommendation we make has to be affordable by farmers and has to fit his socio-economic condition. So that's one thing I wanted to bring your attention on. The other one.
Yes, would you mind being very short?
Yes, I'm making it short. The other one is when we think of things like biochar, it's very good for soil fertility restoration, but the other thing to consider is that the cost effectiveness of that technology. Is it something that farmers can produce easily, or do they end up burning more fuel to produce biochar on their farm? So these are things that we need to consider when we are working on environmental mitigation. At the end of the day, it's all about optimization. If we improve in efficiency, we will get there. So those are the comments I wanted to make. Thank you.
So thank you for your comment. But at least you have at least two questions. What would we do with the soil map of soil fertility, and what your question on biochar? But what I would like to, I will not give the floor to the panelists. I want you to take the floor and to maybe to respond, to comment what has already been said by our colleague from IFDC. Okay? Who wants? Yes, please. If the debate is between the audience, we are very happy with that. Not only with the panelists. So take the floor. Yes. And again, if I may, if you want this session to be very interactive, be short, sharp, and straight.
All right, will do. All right, good day, everyone. My name is Tondoh. I'm from Botswana. I'm into artificial intelligence research by profession. I'm an AI engineer. So I'd like to make a comment on, I came a bit late here, but I think I've heard a lot of things across different fields, from seaweed to agriculture, soil organic matter. So the comment that I'm putting out there is just around utilizing the power of artificial intelligence research in the things that we've just discussed here. One of the problems that are currently there in Côte d'Ivoire, like the doctor here has discussed, was around soil organic matter. That's the data that's already there. So one of the researches that we do is around real-time disease detection, real-time prediction of soil organic matter. We're utilizing drone technology and satellite data, including the data on seaweed. Almost all the problems that we discuss here is the data that we already have. All the insights that we discuss here, the measures about going around everything. Like the good say here mentioned, this was around efficiency, cutting all the turnaround times for the processes that are already there. That's the data that already exists. So my comment was just around utilizing the power of large language models, multimodal large language models, and artificial intelligence and the processes that are already there. Currently, a feature that we're just putting out there that's already there in the market is just utilizing the power of artificial intelligence in a very cheap way by utilizing social media networks. Because currently you can access that data, that power of artificial intelligence just through WhatsApp. Almost everyone in this room has access to WhatsApp. Just doing detection through WhatsApp, getting all those insights that I just mentioned through WhatsApp. So that's just a comment that I'm putting out there, utilizing AI into everything that we already have.
Thank you so much for your contribution. Another, yes? Yes. Madam? Yes, would you mind? I'm sorry, there is nobody to make the mic moving. Sorry.
Hello, I'm Jacqueline Hanneman from the British Society of Soil Science. It's a question that kind of connects some of these questions already, I guess, is thinking about the sort of barriers to adoption. So we're talking a lot about acquiring lots of data through AI or digital soil mapping, but turning that data into information. So what is the soil doing, but what can the farmers actually do? So it's a question, I guess, to most of the panelists about how they're disseminating that information. We talked about carrots and sticks at different top-down approaches, but certainly I've seen in the UK the real barrier is for adoption is actually providing information to farmers themselves, and not from politicians or scientists, but from each other. So if people have some examples of those sorts of networks, that'd be really good to discuss.
Yes, maybe we can take one other next comment, and then we give the floor to the panelists, please. Thank you.
Thank you. Building on from that question, Michael Lee from Harper Adams University in the UK. We all know that farmers are absolutely vital to these global solutions, but they've also been getting a lot of stick associated with carbon emissions, particularly livestock farmers. And we've heard today about the importance of manures in soil health. But have we got enough global information? It possibly links with the AI question. Have we got enough global information about carbon stocks? And also a program where we assess soil regularly enough to determine soil sequestration potential. We heard about 4 per mil. But what? Because we know farmers are the agents for change, but they need to be given the tools. And also, they need to be given the benefit and the example of the carbon stocks they already protect, particularly in terrestrial lands. And obviously then the role that livestock and regenerative farming has. Thank you.
Thank you for your question. And maybe we can just...
I can respond to that.
Yes. May I ask you to be very short, just to... Yes, thank you.
So, thank you for the question. Can you hear me?
Yes.
Can you hear me? So, what you say is true, and many people out there are doing this. Our company, a sister concern, is building a full-stack digital platform where we collect all the data from around the country on various parameters of sea, obviously because we're interested in seaweed. That includes the physical parameters, the biological parameters, and the chemical parameters. We merge that with AI, with satellite imagery and GIS, and creating algorithms in order to be able to foresee which are areas which are suitable for seaweed and which are not suitable, and if they are suitable, then which species of seaweed. So the platform is already in place and we are doing this, except that the data is an ongoing process.
Thank you. Any other comment from the panelists?
What
Jérôme?
I want to say is that we are talking about smallholder farmers. We are not talking about, I think, big people with large farms in Brazil, even in the Western country. No, smallholder farmers. On average, 1.5 or 2 hectares. Okay? So I'm not sure that promoting manure will have detrimental effect on climate change instead of using it. I don't know if you catch my idea. For instance, you know what is going on globally, the uranium crisis, Russian uranium crisis, and the farmer cannot afford to buying, I think, fertilizer. So the only option you have is to make sure that you are making the most out of waste, agricultural waste that are spread throughout, I think, agricultural landscapes. This is the point. How can we, I think, make good use of those wastes that we frequently, are frequently available in those farms? Like in Côte d'Ivoire, for instance, per year, more than 20 million of waste are produced, and no one is using them. So how can you make good use of those wastes? This is a question. Thank you very much.
Thank you, Jérôme. Maybe we can move very short.
Now, regarding the carbon content in the soil, the natural farming has many results. He has not given because of the paucity of the time. Otherwise, we have that if a farmer is utilizing the natural farming technology, which he has given 4 principles and other things, then carbon content of the soil can be increased, which was earlier in the same field was 0.3 or 0.2, now has increased to the level of even 1.5, 2.5, 4.5. But certainly, the organic matter content must be given to the soil so that the soil health can be improved like anything.
Thank you. It's over to you, Paul. He has a difficult task to wrap up, but also to complete or to complement what I've already said. Good luck, and thank you so much.
Thank you, Jean-Luc. Well, it's not really a wrap-up that I propose to you. It's just some idea that were already in the room with the presentation. And I just would like to make a travel with you about this question of soil. If you look at the SDGs, now it's really clear that about 7 to 8 SDGs address question of soil. Soil are very important to address those SDGs. That's the SDG, I say, directly concerned by soil. The first ring that GSP showed. The other one is almost the rest of the SDG are indirectly related to soil. Okay, so the morality of that is that if you are not taking care of your soil, you will never reach the objective, the Sustainable Development Goals. So I put an emphasis on some of them. I was not really agree with them. This is not my production. I was not really agree with the last one. I think the most important are there. That's life on land, climate action, sustainable consumption and production, well, production and consumption, improve the quality of land and the food for the people, and health for the people, and of course, relation to water. That's the major SDGs that are touch or directly in relation with soil. On the other hand, still belonging to the UN system, there are the 3 Conventions of Rio. So I took the example, well, it was before COP28, so I didn't take stock of what happened already in COP28, but I can include that in my presentation. In COP15 in Abidjan, on desertification, and it's a long time that COP already included that question of land health and soil health. This is really addressed, and we all know that without soil health, healthy soil and healthy land, we'll never reach desertification objective, this convention objective, sorry. In COP27 in Sharm el-Sheikh, they're continuing work, including agriculture, more and more in the discussion. And soil and soil health were promoted by some, but not all. And there were numerous pavilions talking about agriculture, food system, which is a new concept. Well, it's not really new, but it's coming again new. And we transformed the trial of the Coronivia joint work in agriculture to the Sharm el-Sheikh joint work in agriculture and food system and so on. It's become too long now to say all those letters. So it's clear now that concerning climate change fighting, agriculture is really the unique sector that is not only part of the problem, but it's also part of the solution. And we all know now that without agriculture and the work on food system, we'll never reach the objective of the Paris Agreement. So from the beginning of COP28, and we are a little bit more than after the middle of this, there is something that we really appreciate, that the declaration that was signed by 134 countries, now it's a little bit more, I heard that it was more than 150 that signed it, concerning agriculture, food system, and soil health, for the very first time was mentioned in that context of climate change fighting. When we come to the last COP and the last convention on biodiversity, I was in Kunming, Montreal meeting, Montreal meeting for Kunming last year, and it was clear that there, in that context, the problem is agriculture, and mainly intensive agriculture, deforestation, which is really harming the biodiversity of the world. And even though soil health and agroecology appear in the last declaration, and it's not yet considered as really part of the solution, and we need to continue to work on that. From now on, there are more and more initiatives working on soil health, agroecology, ecosystem restoration, and so on. I give some examples there, but this list is not exhaustive. And from 2022, we work closely with the CASH Coalition, Coalition for Action on Soil Health, and we promote at the international level, at the level of the policymaker, the fact that they need to consider soil health as really an important question at the highest level. And we propose a resolution. We push this resolution in Sharm el-Sheikh. We got no result. We push a little bit more here. Well, at least we have a beginning of result, which is not too bad, because in those days where the bad news are more numerous than the good news, it's good to say that there are one good news. Just before this COP, we produced with CIRAD and ERD a policy brief on healthy soil sustained food system transformation to contribute to the net zero CO2 emission target by 2050. That's very easy to read, and directly you have the 4 pillars and our recommendation. It's a 2-page document, so we will provide you the place where to get it if you need. You can find it on the CIRAD, on ERD, or the 4 Initiative website. And the STC, the Scientific and Technical Committee of the 4 Initiative, produced another policy brief on the role of soil for resilience to climate extreme and climate change for food and water security, which are also another very important problem. It was mentioned by Jean-Luc at the beginning of this side event. The 4 Initiative, which is now 8 years old, produced 3 years ago a strategic plan, including 24 objectives that if by chance, and I hope that we will do it, we fulfill by 2050, then we will not need any more the 4 Initiative. We will disappear. And maybe it will be a pleasure for some, but well, we are not yet here, and we need to work all together to reach that. And I would like to share with you our vision of the world in 2050, a worldwide healthy and carbon-rich soil to combat climate change and hunger. So if I want to summarize all what I said, healthy soil are carbon-rich soil, and they help through carbon sequestration to fight climate change. Healthy soil are soil rich in organic matter, full of life and biodiversity, which can support high biodiversity level below and above soil. Healthy soil are soil rich in organic matter, which can absorb high quantity of water to be used by plants and which are less sensitive to erosion, to wind and, of course, water. And it means that could help for combating desertification. Healthy soil are fertile soil, allowing agricultural production on the long run with stabilized yield and help fighting food insecurity. So, in summary, in a nutshell, without healthy soil, no hope, no solution for the Convention on Climate Change, Convention on Desertification Fighting, Convention on Biodiversity, and for the work of FAO on food security. If I have to give you some take-home message that I get from this side event, I would say that we heard about the fact that there are many ways of making agriculture friendly to soil health. Agroecology is one of them, but agroecology is not a solution, it's a group of solutions. And natural farming is part of it, organic farming is part of it, conservation agriculture is part of it, agroforestry, regenerative agriculture, holistic grazing system, whatever. I mean, there are a long list of all possible solutions. That's the first step. Second one is that we heard about co-construction. You will never reach success without the farmers. It was said by many people. And the farmers have their word to say now to go after the Green Revolution, who was led by scientists. Now, most of the knowledge, traditional knowledge, are in the hand of the farmers. So how can scientists work closer to farmers in order to co-construct the orientation for tomorrow and help to scale up the real solutions that are working in the field? Last but not least, we need to really increase the awareness of the population. We need to give them the right information, where they can find the right products, produced correctly. We need to increase the awareness of the policymaker. Why do you continue to ignore the importance of soil health? We were talking about reorienting subsidy. Definitely we need to reorient subsidy, because if we want subsidy to be not harmful but helpful, we need to help the farmers to get them. So listen to the farmers a little bit more and try to push in that direction. And I appreciate the presentation of seaweeds that seems to be completely out of soil, I would say, from that side event. But it brings also the solution. I mean, bringing people more outside the land, go to the sea where there are rooms, and using also the capacity of seaweeds to capture carbon. That is also the blue economy, as you mentioned. So, a little bit of publicity before we left. All that I said is in this book. If you appreciate what I said, please purchase the book. I have no right on that. This is all going to the 4 per Mil initiative to help us continuing our work to fight and help farmers to, not to get the power, I don't like that, but to be more present in the discussion, more present in the governance, and having their word to say for the orientation that we propose to the world. I think it's also good for the consumer, I think. And I thank you very much for your attention.
So thank you. We are at the end of the event. We would like to, thank you very much. And all my colleagues have introduced themselves. So I am Jean-Luc Schott. I meet that from the French Research Institute for Sustainable Development. And I was very pleased, I am still very pleased to have been your moderator. And if one of your comment of your question has not, have an answer, do not hesitate to send an email to one of the panelists or to myself, Jean-Luc Schott @ird.fr. We will reply collectively. Thank you so much. Have a nice end of the day. See you.